Tonight, we're going to embark on a Royal Institution murder mystery investigation. And this is our crime scene. But there's no body. And actually, at first sight, there's nothing to suggest that even a crime has taken place. Until you start to look with a more forensic lens. I wonder what we might find. Join us as we try to piece together the evidence to solve a murder mystery when the body is missing. In this, the second of the Christmas lectures at the Royal Institution, we'll reveal how the police use forensic science to investigate and interrogate a potential crime scene. Much of the evidence that we'll collect over the next hour will depend on a fundamental premise of forensic science known as LOCAR's exchange principle. When there's a contact between two items, then there will be an exchange. When we enter into a space, there'll be an exchange. We will leave with something and we will leave something behind. So, can I have a first volunteer, please? Would you come forward for me?
Can I ask your name?
Millie. Millie, would you mind just sitting on a step there for me? And what we're going to do is we're going to show the principles of LOCAR's exchange. Now, if you come down and stand here for me, when you step into the paint, mind you don't slip. Okay, all right, yeah, and the other foot. Now something's changed because there's something on the bottom of your shoes. And when you walk down that piece of paper to the towel at the end, let's see what happens. There's no great mystery there, is there? We knew that would happen. So the exchange is that every time that that sole of that shoe touched on the paper, something was exchanged. And that's easy when there's evidence. Thank you, Millie, very much indeed. Thank you to Millie. But that's easy when we can see something. But what if the evidence we've got isn't easily seen? So if we pop the lights down for a moment. May I? Okay. So what you have is a special torch, and we're looking for some evidence that might be around you somewhere that you just can't see. And if we use the torch, that may help us. Can you see what we got? We've got a footprint and a Christmas message at the end. Of course we have, haven't we? And that's the very fact that sometimes we can't always see the piece of evidence until we do something with it. And that's the key to unlocking this world of forensic science. If they change the way we look at it and we adopt a more forensic lens, then we can reveal previously unseen details. And if we've got a crime, then both the victim and the potential perpetrator, they may well leave trace amounts of evidence behind as well. What sort of things get left at a crime scene? Fingerprints, DNA, hair, all sorts of things. And we're going to have to find them, and we call them trace evidence. So over the course of this lecture, we're going to recover as much from this crime scene as we possibly can to try and determine what may have happened. Now, I'm a forensic anthropologist, and my job is normally working with human remains. We haven't found any of those yet. But I'd only be one member of the science team. There'd be a whole lot of other ologists around, people who might be studying different types of trace evidence. But the most important person in the team is the person who leads it. And the lead police investigator is known as the Senior Investigating Officer, or the SIO. So I now ask you please to welcome an extremely experienced SIO from the Major Crime Unit at Hertfordshire Police, and he is Detective Chief Inspector Sam Kana. And he really is a police officer. Thank you, Sam. I'm really grateful to you for joining us because I know you're very busy at the moment, so thank you. Can you describe to us perhaps what it is that you do in your role?
Absolutely. So I'm accountable for every part of the investigation, which includes being the lead investigator and also the manager. And a key role for the manager part of it is the welfare of my team, because as you can appreciate, we deal with some really challenging investigations.
Yeah. So we've set up a crime scene here. I'm sure it's not the most challenging crime scene you've ever had in your career, but it's going to be a memorable one. How do we start?
Well, before I attend the crime scene, I would have received a briefing and some basic inquiries would have been completed. So we're dealing with a missing person here today. So friends, associates, work colleagues, when have they last seen the missing person? Some CCTV inquiries. But most importantly, we need to obtain a photograph of this missing person, which I happen to have. We've got an evidence board over here. I'm going to just place the photograph over here, along with other bits throughout the course of the lecture.
And when you've got a missing person, which we also call a misper, time is clearly critical. How do you strategize? How do you start?
Well, so student officers, when they're trained, will be taught about the building blocks, as we call them. So the number one priority is preservation of life. So if they attend a crime scene and there's clearly someone in need of urgent medical attention, that's their priority. In this scenario, we don't have an obvious casualty, so then it moves down to step 2, which is the preservation of the crime scene. So before anything is touched, photographs will be taken.
And before we started this evening, we asked somebody if they'd be prepared to be our forensic photographer. So would you come forward as our forensic photographer, please? And your name is?
Millie.
Millie? Millie, I'm going to ask you to go away and get yourself all kitted out, because Millie is going to be with us for the rest of the evening. She's going to be in her crime scene suit and she's going to be taking photographs, because those photographs are really important. They're a record of anything that happens. And we always take thousands of photographs at a crime scene, but there's always one, which is the one we didn't take, that you as an SIO always want. It's
Most
inevitable,
definitely.
isn't it? So the first officer who came onto the scene reported that there were traces of blood in the kitchen units. Could you identify where those might be?
Yeah, absolutely. Well, I'm looking down the side of the cupboard here, and there's certainly a red substance, which I'll be extremely interested in. Common sense would say it's blood, but we need to confirm that fact.
And I can just confirm around the room, don't worry about it. It's not really blood. We've put it there, but it's something very nice and red, so please don't worry about it. Now, once you've got blood, does that change the priority of your case?
Well, absolutely. I mean, it could be that this has been placed here by accidental means, but certainly I'm extremely interested in this. It looks like a significant amount of blood. We've got utensils tipped over here. Might be nothing, might be signs of a disturbance. And actually just spotting down here on the washing machine, it looks like a fingerprint in some sort of red substance, could be blood. So has there been a clear up? I would certainly be interested in exploring around the washing machine.
Is our photographer ready? Excellent. Here she comes. Millie, thank you. Thank you for agreeing to do this. You're going to be our photographer all evening, so I'm going to call you. I'll want you to take a photograph of something, and I'll want you to hand that photograph to our SIO. We'll call him Sir.
Right.
So are you ready to go?
Yeah.
Are you sure?
Yes.
What are you missing?
Camera.
Absolutely. Can we have a camera, please? You can't be a photographer without a camera. So this is what's going to happen every single time. Photographer!
Okay, could I have a photograph down this side of the cupboard, please?
Oh, there we go. It's a flash. So, oh, there you go.
we go.
And, sir,
Sir.
Thank you
Thank
very
you.
much. And could I please also have a photograph of the mark on the washing machine?
that's it.
Thank you very much.
Right, thank you very much indeed. That's the photographs we need for the moment. So, what would we do next?
So we've got the mark on the washing machine here. So I'll be extremely keen to see what's inside that washing machine. So potentially that's an
So,
area to look
with
in.
your permission, sir, can I open
Please
the
go
washing
ahead.
machine? Thank you very much. Not touching that. And inside the washing machine, there looks as if there is a tea towel. And I pop that in an evidence bag. So we're going to want to see whether we can get any form of evidence out of the T-towel. Okay, thank you very much indeed for that at the moment. What I'm going to ask you to do is I'm going to ask you to welcome Isla. And Isla is from the RI's demo team. And she's going to show us what we're going to do in terms of identifying blood. Isla, thank you very much indeed.
So one way we can search for blood is to use a chemical called luminol, which is what I have in this flask here. And forensic teams might spray luminol on a surface when they're looking for blood. There is a reaction between the iron in the hemoglobin, which is in our blood, and that reacts with the luminol and it produces a bluish glow. So that's what we're going to look out for.
We're looking for a blue glow
We are.
when this chemical goes into that's simulating blood.
That's right.
I think it requires a Royal Institution countdown, don't you?
think
Let's
so.
get a little bit of noise in the room. So on 3, 2, 1. Anytime that luminol is used, we are looking for that blue response.
That's right.
Okay, can we now look at the tea towel? I've placed it in the evidence bag under here. So here's our tea towel from inside the washing machine. And you're going to spray this with luminol.
Yes.
Now, I know you've seen CSI something or another, or any of these television programs where things come out as bright blue that you could see them from space. The reality of science is different to television. So we will have to look very, very carefully for the blue glow. So if we can bring the lights down again, it will only happen really transient effect. And we need to be prepared to be able to see that. Okay, whenever you're ready, Isla.
Okay, I'm going to start spraying now.
Okay. There you can see just that blue luminescence. I think the SIO would agree that we need to send this tea towel for a bit more interrogation. Thank you. And with the greatest of respect to Isla, doesn't that seem like a very slow process? And technology has moved on and continuously moves on. And that's the important thing about forensic science, is it doesn't stay static. And we have new techniques being developed all the time that allow us to look for evidence in different ways. So can I ask you please to welcome Dan Scross, please. That's your camera. Dan very kindly let me play with his camera, thank you. And I know it's an extremely expensive camera. So Dan, tell us what you do and what this piece of apparatus is all about.
Yeah, absolutely. So I am a product specialist for a forensic science technology company. And the piece of kit I have with me here today is a multispectral evidence search kit. So what this includes is a whole array of LEDs, integrated filters, and a high sensitivity digital camera.
It looks like a bit like a daisy on the outside,
absolutely.
doesn't it? Okay. And we're going to ask you to have a look at our kitchen to see if you can see something.
Yeah, so what I'm going to do, I'm going to connect the device just so you can see what the camera is
See it on
seeing.
the camera.
So what I can tell you is that the finger marks on this counter have been powdered with a fluorescent powder.
So is that the yellow marks that we're seeing on here?
Absolutely.
Because from here I can see them really clearly.
The fingerprint powder is absorbing the light, so emitting a fluorescence.
Okay. And anywhere else that we could see
Yeah,
this?
so we can look around everywhere, yeah.
So these have already been dusted, haven't they? So that's why we can see them. So our scene of crime's been in, dusted them over. You come in with the camera, and now we can see them.
Absolutely, yeah.
So welcome to the magic, and it is magic of the Royal Institution, because our kitchen is going to disappear, and I'm going to introduce you to our sitting room. And our sitting room is a wonderful set of patio doors and a rather striking pair of curtains, if I may say so. So, we're in our sitting room now, and we're looking at a set of curtains, but I can't see anything in here that would cause me any concern whatsoever.
But look what happens when I switch on to our infrared light source. Suddenly we can see some staining there that we simply couldn't have seen before.
So there, just at the end of my fingers, can't you? There's a sort of streak there. And you can see other patches. So what's this doing?
What's happening is the background, or the substrate, is reflecting the infrared light, so appearing lighter, and the stain is absorbing all this infrared light, so appearing darker.
It's only picking blood up.
In this instance,
In this instance, it would pick up blood.
Yep.
I suspect, I don't know about you, but if we've got blood in a curtain, don't we need to open the curtains? 3, 2, 1. And now we can see that there is something for us to look at. Photographer! That's a good photographer. So, Dan, thank you very much indeed. Thank you for showing what your camera can do. That's very much appreciated. Thank you. There's a huge amount that we can learn from the way that blood spatters, and it's not splattering, it's spattering at a crime scene. And to see how the spatter analysis can be applied to a crime scene, I need to have my two messy volunteers, please. So your name is Tristan. So we have Tristan, and we have Dennis, okay? Now, one of you is going to get seriously messy. Who wants to go messy? We're going to do it. We're going to send you off out through that door over there. You're not going to get quite as messy. So what we're going to do is we're going to ask you to pop on a pair of incredibly gorgeous wellies. We're going to try and see what kind of a mess you can make in blood spatter. But of course, it's not going to be blood. So what we've got over there in the bowl, you'll see there's one of these cannons that you use in the swimming pool. It's full of paint, so I want you to come here. And what we're going to ask you to do, if you take that, what I want you to do is I want you to create a pattern that goes up that piece of plastic. Excellent. Okay, go and pop that one down. And there it goes, starting to run down. What I want you to do with this is I want you to take the paintbrush and I want you to just flick it at that side of the wall. Okay, that's okay. That's not a problem because that leaves you a mark on the ground as well. Perfect. Very, very different. Thank you. Pop that back. Very different pattern on that side that we have on this side. Now this one, this is where it gets slightly messy. And what I want you to do is I want you to go up to the puddle and I want you to stamp in it, okay? There we go. So you can see that what we've got three types of spatter there. Great. Thank you very much indeed. Thank you for helping us. Now, I know that this feels like it's a bit of a game, but interpreting these different types of patterns is actually really useful because forensically what it does is it tells us what actions are occurring. So to our SIO, this blood spatter patterning that we've got, what would it tell us?
As you can see, we've got three very different types of patterns here. Could this long blue one be projected?
Yeah.
Could this green one here be impact, so force coming into contact with wet blood, spraying it apart? Could this one here be cast off, so could it be a weapon that's then withdrawn?
And I know you're not a blood spatter analyst expert, but if you remember the pattern that we had on the patio doors, does it look like one of those more than the others, do you think?
Absolutely. Well, I think everyone would agree that this pattern here, the flicking up, the cast of blood, would be the most likely.
So that's the most likely. Now, what we're going to do is we're going to bring in our other volunteer, please. So can you welcome Dennis back, please? I just want you to stand there. Keep your chin down, okay? You'll be fine. Can we have the cannon, please? So Dan, from the demo team, would you join us, please? I promise it doesn't hurt much, okay? You ready? On 3, 2, 1. Ah! It's okay. Now listen, what it does do though for us, if you just come over here for a moment, it does show us that everywhere that you were standing is quite clear. And that's called a void, because when you were hit by the paint, you created a barrier between the paint and the wall behind you, so that we would know that there was something had occurred in that space. We didn't find it at our crime scene, but it's just an opportunity to throw some paint at anyone, and you have been a tremendous sport for it. Thank you very much indeed. Now, Sam, we've looked at that blood spatter now. What is it that you think we need to do next?
The blood spatter has given us some really good clues about what might have happened here. We can now start to disturb that evidence by taking some samples. Can I have some Scene to Crime officers, please?
And their job is to find the trace evidence so that we can see it and then we can recover it and we can analyse it. Would that be right?
Absolutely. There will be fingerprints and DNA.
So the two that we're really quite comfortable with in many ways in terms of a crime scene. Thank you at this moment. So it's always possible that that DNA that we get back may give us a hit on something that's called the National DNA Database. And that DNA database holds the DNA samples of individuals who have been convicted of crimes. So on everything we touch, on that low cards principle, what we have is we leave a trace behind. And so I need somebody who'll also be a volunteer for me. Right in the middle. Would you come down, please? Thank you very much. And your name is?
Isabel.
Isabel. Isabel, what we're going to ask you to do is on this pane of glass, and I'm hoping you're a little bit hot and bothered because you'll leave it good, you'll leave a better sample. So I want you to leave a solid handprint over in this corner here. Push your hand on there. Perfect. Then what I want you to do, and this is going to feel really strange, okay? I want you to pick this up. Would you give it a great big kiss? Right there. Off you go. You're a great sport. Thank you very much indeed, Isabel. Thank you. Now, we know that we've got prints or some form of prints on this piece of Perspex, and we're going to need somebody who's going to be able to help us, a fingerprint expert. So can I please introduce the expert, Claire Lynch from West Midlands Police Force, please. What do we need to do to make those prints visible?
We need to put a development medium onto them.
Okay.
So we will use some sort of powder, that be a black powder or aluminium, and we will try to get that powder to stick to the sweat or the grease.
So what we've done is we've got some black powder here, and Isla, who's from the RI's demo team, is going to help us to see if we can see these prints by placing some of the powder on it. So just the brush into the powder?
So yeah, we'll just pop the brush into the powder, very, very gently, just brush over that surface to try and get those prints to develop.
There we go. And I think I can see a nose and I can see a pair of lips. Now, it's perhaps not that easy to see, but if we pop that piece of paper up, that might make it a little bit easier for you. Now, so we've got a bit of nose, we've got a mouth. Isabel, we'd recognise you anywhere. Why do we see these prints?
Fingerprints are, when they're deposited, they're in their latent state, so we can't see them. They're just sweat and some
sweat.
minerals and some oils.
Okay.
So what we need to do is put powders on to get that powder to stick to that sweat so that we can see the fingerprint, so that it can be recovered and examined.
Excellent. But of course, we've got prints on the crime scene as well. So what do we need to look for there?
So our SOCOs have already been out and they fingerprinted certain areas, and they've left a latent print on the glass just here.
Okay.
We need to lift that so that we can submit that for examination.
And I'm okay because I'm wearing gloves,
Yeah,
so I'm
and
not going to leave my print behind.
That's correct.
Okay. So if we take this over to here, and if Isla, if you could come back.
So let's first of all put some paper in so that Isla can see where she's lifting those prints from.
So there. Yeah.
Okay, so we're going to use a low-tack tape and we're going to lift the actual powder off that glass.
So what you're doing is you're using the sticky tape to remove the pattern that's been made by the black powder.
Yes,
is that right?
That's
okay.
right.
So
we'll take that off very, very slowly.
And now, what do you do with it now?
We stick it onto a piece of acetate. So pop it into the centre there, and then just make sure that that powder then sticks down.
So what you've created is a sandwich.
Yes.
You've got a sticky layer, you've got an acetate layer, and you've got the print sitting in the middle between them.
Yes.
Okay. And now back to our murder mystery. So what we have is there's a knife that's missing, I don't know if you noticed, from our knife block. And the SOCOs have found a knife. And we're a bit suspicious that it might have fingerprints on it, but we're not going to be able to lift it with powder. So if we could bring in Mariam Ula, who's from the University of Leicester. And thank you, Claire. Now, when we were looking at our crime scene, what we found was this knife down at the base of the wine rack. And There's a suspicion that there might be a fingerprint on here, but we don't know.
Okay.
And we've heard that you have an interesting way of maybe being able to show a fingerprint. So would you take us through that?
Yes, so what I have got here is a solution made of copper, and the knife blade is made of steel, which contains iron. So I'm just going to dip it in here,
Right.
and we wait.
And how long do we wait for?
A couple of seconds. So if it was very warm, I would be taking it out instantly, but since it's a bit colder today,
So we can just hold that
to
that way. What I can see is that the colour of the blade has changed. And I can also see 3 on this side, and if you turn it around to the camera, 4 on that side, much lighter patches. And those are fingerprints.
Yes, so what's happened is the copper in the solution has formed a film on the surface everywhere except where the fingerprints are. So we've got a negative image of fingerprint.
So when we get fingerprints left on metal, and there can be all sorts of metal, it might be a knife, it might be a gun casing, it could be anything like that. This is a way to lift fingerprints of metal. It looks to me as if we have some fingerprints on a knife, we have fingerprints on a glass. I'm hoping, she says, looking at our senior investigating officer, that he's starting to get a little bit happier.
Fantastic.
I don't know if he looks that happy to me. Does he look that happy to you? I tell you, they're a difficult bunch to work with, senior investigating officers. And thank you, Miriam. Thank you very much indeed. Thank you, everyone. So what I'd like to do now is I'd like to welcome Claire to come back and talk to us about fingerprints. Claire, thank you. We've just managed to recover some fingerprints, but I wonder if you could talk to us about what it is that we're looking for in a fingerprint.
Okay, so we're going to put some images up on screen, see if you can spot if you've got that pattern or not. So our first pattern is a loop. So we have where they're ridges, these black lines, there are ridges, and these go up and over and round, a little bit like a hair grip going round. Then we have a whirl type pattern, and it goes round in a circle.
It's a bit like a snail shell.
Yes. I suppose, have most people got those patterns?
Yeah? So those quite common patterns?
They are quite common patterns.
Okay.
And then our next main pattern is an arch type pattern. So this is where the ridges will go just from one side to the other with nothing going on in the centre of that pattern. So with that, we use that as our first level detail. We can then look at our ridge characteristics, and those ridge characteristics are what make everybody unique. So we will be looking for our ridge endings, our lakes, which is where we have a split in the ridge and it opens up and then it all joins back together. We have a bifurcation, which is where we have 2 ridges that split and just go into one. We have an independent, what we call an independent ridge. And that's just where we have a tiny little bit of a ridge detail. And then we have other ones called spurs. Now that's where we just have, off that ridge, we just have one that just pops off just a little bit, and then that stops. So they're the ridge characteristics that we will start looking at.
So do we have databases for fingerprints?
We do. We have an AFIS database, which is made up of everybody who's been arrested.
So next thing is, if we've got a fingerprint and you've got a database, what do we now need to do?
Well, we will search that fingerprint on the database, and the database won't tell us whose that fingerprint belongs to, but it will bring back a list of candidates and saying, we think this best matches this 15 people.
And this is where your expertise comes in, is that you compare one print with another. The computer may sift through them, but you compare one print with another, and it's your decision when you go to court that says, I think these prints match.
Yes, that's
So
correct.
we're going to do a comparison,
We
aren't
are.
we? I need to have a volunteer to do the comparison. Yes, please, come down. You come and join me and just tell me your name. Micaiah. So we're going to ask you to do a fingerprint comparison. Now, how many years has it taken you to get to this level of expertise, Claire?
About 17.
Okay, you've got 5 seconds, okay, to get up to the same level of expertise. So I'll let you, Claire, take
First
it away.
of all, if you stand this side for us. So this is our crime scene mark. Does that first level detail match our first level detail on the AFIS set? Yes. Right. We're now going to start looking at our ridge characteristics. So I'll start you off with the first ridge characteristic. We'll pop it straight in the centre and we'll go for a ridge ending. Okay? So our first one is we'll just put a big old dot straight on there on our crime scene at that ridge ending right in the middle. And then we'll come over to our AFIS set, and that ridge characteristic there is in the same place, so we'll mark that one up. I'm going to hand you the pen.
No pressure.
So, what's the next ridge characteristic that you think you can see? So if we pop a dot on there, yeah. So we'll go for our next bifurcation. And just above that, what was that one? Spur. Spur. So we're going to mark that spur up that's just there.
It's hard, isn't it? It's really hard. I must admit, I look at patterns like that and I have real difficulty seeing it. So well done. That's a really good set of matches that I think you've got there. So
Yes.
thank you very much indeed for that. Very much appreciated. Now, I know you've just started to mark this up, and you'd go on and you do a lot more than this.
Yes.
But in your expertise, is there anything interesting about these two prints to you?
The ridge characteristics that we can see in our crime scene mark,
Which is the one from here.
which is the one from here,
Yeah.
matches the ridge characteristics that are on our AFIS set.
So you're saying that this print comes from somebody who has previously been convicted of a crime and we already have their fingerprints.
Yes.
So we should be able to get a name from that. Now, this doesn't mean at the end of the day this person's done anything wrong.
No, it doesn't.
All we're saying is they have the same
Yeah.
fingerprints. But isn't it nice that we could get to a point of saying perhaps we've got somebody to investigate?
Yes. Once we've actually checked all of our ridge characteristics, we'll make a report of identification and we'll send that over to our SIO.
And what do I need to do now? Photographer! You are going to see the happiest SIO on the planet. Lovely. Okay, Claire, thank you so much indeed for everything that you've told us tonight about fingerprints. When our SOCOs came in to take the prints, what we did was we found actually there were a number of individuals who were involved in leaving their prints behind. And what we're going to try and do now is to gain a bit of extra information about the prints that we found and to build a story about what might have happened. Now, when you came in, you were all given a booklet. And in the back of that booklet, you should have a fingerprint. Can you take out your fingerprint? What we've got here is a map of our property. We know that we have a kitchen because we're standing in it. And if you remember, we had those wonderful set of patio doors. So we know that we have a sitting room. Now, you don't all have the same fingerprint. So what do we have? We have loops, we have whirls, and what else do we have? Arches! Thank you. So loops and whirls and arches. That's the most important thing for you to look at. So when I bring up our first print, I want you to look at this print in terms of loops and whirls and arches. And if you think that is your fingerprint that you're holding on the card, I need you to put your hand up. And what I'm going to do is I'm going to come to someone and I'm going to ask you what's written at the bottom of your card. Okay, so what's written at the bottom of your card?
Living room coins.
Living room coin. Keep your hand up, everyone else, except unless your card also says living room coin. So living room coin goes down. Okay, so we've got one. Tell me what's written on your card.
Kitchen toaster.
Kitchen toaster. If you've got kitchen toaster, your hand goes down. Kitchen flour jar. Okay, kitchen flour jar. If you've got kitchen flour jar, your hand goes down. Okay, right up at the back, in the red jumper.
Kitchen bin.
Kitchen bin. So if you've got kitchen bin, your hands go down. We've still got a lot to go. What do you have?
Bedroom wardrobe door.
Bedroom wardrobe door. That's yours. Put your hand down. And we'll maybe take one more.
Living room light switch.
Living room light switch. So let's just stop there with that particular print. And I know we've got it in lots of other places. What about the second print? So if you have that print in terms of loops and whirls and arches, I need you to put your hand up. Oh, nowhere near so many. Where does yours say?
Kitchen drawer handle.
Kitchen drawer handle for yellow. Okay, that's interesting.
Kitchen inside door handle.
Kitchen inside door handle. Okay. And in yellow? Kitchen tap. What else do we have?
Kitchen knife.
Oh, my alarm's just gone off. The kitchen knife is on that one. Okay, if we put our hands down, what we've got is we've got two interesting set of patterns. SIO.
Well, this is extremely interesting, but I think maybe I should ask the audience. Yes, over there? What do you think about the different colours? Any differences between the blues and the yellows?
The yellow are mainly in the kitchen, and that's probably the murderer, and the blue are throughout the house, so they probably live there.
Fantastic. I might have to offer you a job, I think. Absolutely, I agree, because the blue fingerprints are all recovered from general household areas, but the yellow ones are really interesting. As you say, they're all centred around the kitchen, and most importantly, that knife. So I'm extremely interested in those prints.
Yeah. Good. That shows that you've been able to look at a pattern of a fingerprint. You've been able to compare it. And in that comparison, it's given us a piece of information and intelligence. So we're slowly starting to piece together that evidence. And it's telling us the story of what's happened here, or might be telling us the story of what's happened here. So what would you do if we want to be able to search for a body? How do we do that?
Well, we've got our eyes, but there's much more powerful resources we can use. So I think at this point it would be a good time to get in a dog.
I think it would be a wonderful time to get in a dog, don't you? So I'd like you, please, to welcome Ozzy and Paul. Good girl. Paul, thank you so much indeed for taking Ozzy. Ozzy is an award-winning dog, is she not?
She has been decorated, yes.
Yeah. and tell me, what would be the right term?
Ozzy's referred to as a victim recovery dog. She's trained in relation to detect bodies and blood, or if we're concerned for somebody who may be missing.
OK, so what are we going to do with Ozzy? She looks as if she's ready to go.
She's raring to go,
She
I think.
is, isn't she? She's totally unfazed.
OK, so first off we would do on the floor. So, Ozzy, Ozzy, Ozzy. Look, look. So I'm using my pointer just to try and keep her where I want her to go.
She's really working, isn't she? That nose going.
The nose will go constantly.
And the tail's going too.
Now, if she was to find the substance that we're looking for, in this case, it would be blood, she would freeze.
Okay.
And that would be her indication. So what I would typically do is now I deploy her off lead, as you can see, and I would be looking at any voids or open areas or cavities so that if there was a scent, she would react to it. Oz, you never know, there might be something underneath these voids. What's this? Oh, a little bit of interest. Ozzy, Ozzy, what's this? Good girl. Oz, we're going to go and have a look down here. Here we go. Good girl. Look, look.
Oh, and off out. The camera's going to follow Oz as we go out. And she's off.
She's off. Right, we've got an indication here.
Oh, so she really has frozen.
Okay,
So
I'm going to clip her on.
looks to me as if Ozzy's found something. I'm not sure that's what our
way.
SIO
Good
was
girl.
expecting. But
Okay.
Paul, can you bring out what it is that you found?
Yeah, unfortunately on this job,
Yeah?
looks like a red herring. I'm sorry about
That's
that.
awful. You are so
sorry about
clever.
that.
You are
Good girl.
so clever. I mean, I think the job that they do is just amazing. And when you saw her reaction to that, then, you know, her training is just amazing, isn't it? It's incredible. So I'm sure you want to thank Ozzy as well, and Paul. Thank you
girl.
both. Fortunately, we didn't have to photograph the red herring, so you were okay. Bad pun, so sorry. Right, now listen, the other forensic essential tool that we use to identify is, of course, DNA. So how do we go about using DNA evidence?
So scenes of crime, especially serious scenes of crime, we'll be looking to gather various sources of DNA. There could be some marks on the glass from saliva where someone has drunk from it. There's a hairbrush here. good sources of DNA as well.
Hair gets left on your hairbrush. then
Absolutely. In my
DNA's
case,
there.
a bit too much hair disappears every time I use it.
And what else might you use? So toothbrushes, for example?
Toothbrushes are an
Yeah.
excellent source as well. Yeah, you've got your cellular material and you've got your saliva.
Yeah,
on your
because we always
toothbrush
see
as well.
DNA swabs being done in the mouth, don't we? So a toothbrush is a good thing. And most people don't share their toothbrushes, do they?
Hopefully
So
not,
hopefully
no.
the DNA that's on there is theirs. So moving on from there, what would be the steps for us to go through now?
So first of all, I'd like to know whose blood that
Yeah.
is. Does that blood match what would likely to be the occupant here, the hairbrush, the toothbrush, etc.? And once we've done that, is additional people's DNA present within the scene?
So in much the same way as we did with the fingerprints, where we got more than one set of fingerprints, we can end up in the crime scene with more than one set of DNA.
Absolutely, yeah.
So we're going to have to ask somebody who knows something about DNA, I expect. So to tell us a bit more about forensic DNA evidence, could you please give a warm welcome to the Professor of Genetics from the University of Leicester, Professor Turi King. Thank you for joining us. And as you know, we're going to be talking about DNA. You have a great history in DNA. Why don't you tell us a little bit about your background?
So I got asked to be involved in a really amazing case. So I led the genetic analysis which proved that the remains of a skeleton found under a car park in Leicester was that of King Richard III.
Oh, that was such an incredible case. And so I'd like you to talk to us about DNA.
I will
Floor
do that.
is yours.
Okay. The DNA in our cells is in nice long strands that contains our genetic code. So this is the double helix. This is what our DNA looks like. Now what I'm going to do is I'm going to show you some DNA. And the way I'm going to do that is actually with some spit. This is my spit, so it's a little bit gross. So what I need to do is I need to break down the cell membranes so the DNA can come out of the cells and into solution. The way I'm going to do that is by adding some washing up liquid, just a few drops.
Just ordinary standard washing up
Yeah,
liquid.
I'm going to give this a swirl because what I want to do is I want to get those cell membranes breaking down so we can release the DNA into solution. Now the next thing I'm going to do, we're going to add some salt solution. So all this is just salt dissolved in water. And what the salt does is it helps the DNA strands stick together. And then what I'm going to do is I'm going to add some really cold alcohol. And what the alcohol does is it precipitates the DNA out of solution because the DNA can't stay in solution when there's alcohol. Where those two layers meet, you're going to start to see the DNA, and it looks kind of like clouds. And those are the little strands of DNA. There you go. So that's DNA just there. Now, how do we use DNA for a crime scene? So what we do is we produce what's known as a DNA profile. And I've actually got one here. And it's not the entirety of somebody's DNA, which is known as a genome. What we're doing is it's like we're taking little snapshots of little sections of our DNA that we know are really variable between individuals.
So if we were to think about, we've got some DNA samples that are taken from the crime scene. Do we have a DNA database?
We have a national DNA database. It's not everybody's DNA on it. It's DNA from people who have committed a crime. They're the ones who have got their DNA on the
Nobody
database.
in this room then?
No.
Absolutely
No.
not. So when we were looking at fingerprints, we were able to get a match between some fingerprints in our scene and some fingerprints on the fingerprint database.
Right.
How would we go about doing that similar comparison for DNA?
Well, we need a DNA profile. Now, you can think of your DNA as being a bit like a book. So our DNA is made up of 4 different building blocks, A, C, T, and G. And we are looking at what's known as DNA markers. So bits of our DNA where we know we differ between individuals. And you guys are going to be our national DNA database. That's why you've got these booklets. So the markers that we look at are like a stutter in the DNA. They're known as an STR, a short tandem repeat. So in our little booklet, we have got 23 pairs of chromosomes. 1 chromosome 1 has come from your mom, and 1 chromosome 1 has come from your dad. And that's what we've got here. Now then, let's have a look for one of these stutters. What I want you to do is I want you to go down to line 7, and I want you to look for the word cat. And I want you to count how many times It's repeated. They have to be next to each other, all in a row. If you see a cat on its own, not interested. I want you to do the same for the right-hand side. Find cat and count it up. Cool, okay, so that's one marker. You've got 2 numbers. And we've done that for 6 markers. And they're all done in your book. I want to see if there's a match to the profile that I've got here. So, do any of you have a 10 for either of your chromosome 1s? If you do, give yourselves a little mark like that. If you've got a 5 for either of your chromosome 1s, give yourself a mark. Okay, next one. Chromosome 2, check your chromosome 2s. If you've got a 10, give yourself a mark. If you've got a 9, give yourself a mark. Guys, ready for chromosome 3? If you have got a 3, give yourself a mark. If you've got a 6, give yourself a mark. So you're either going to have 0, 1, or 2 marks. And finally, chromosome 6. If you've got a 7, give yourself a mark. If you've got an 8, give yourself a mark. So now what I want you to do is I want you all to stand up. How many of you has got 0 matches? Okay, if you've got 0, sit down. Sit down if you've got just 1 mark. How many of you got 2? Sit down if you've got 2. Ooh, wow, that's going quick. 5, sit down. 6. Ooh, who's got 6s? So if you've got 6 matches, that means you could be a parent or a child or a sibling of the perpetrator. How many's got 7, 8, 9, 10, 11? Said you've got 12. Okay, if you've got 12 matches, that means you are a perfect match to our DNA profile. And so it's not you who's the perpetrator, but you are holding the sample that is a perfect DNA match. So it looks like we've got a match to our crime scene in our DNA database. And that's really amazing because we've already got a match as well, haven't we, for our fingerprints?
We have a match for the fingerprints, and it looks now we might have a match for the DNA. And it's not always perfect, is it, in terms of a match? Sometimes samples get degraded. There are issues. We don't always get a perfect match. And that's why we go to the experts then for their opinion.
Exactly.
So what else is available to us now in terms of DNA, perhaps that we didn't have before?
Yeah, so what you can do now is, if you want to use DNA and you're looking for matches, is you could take DNA from a crime scene, look at a lot of different markers, and upload it to a genetic genealogy database. And what that does is it's not just looking for a perfect match. You can get matches with somebody who's like an aunt or an uncle or a cousin or a second cousin. And that allows you to build family trees and allows law enforcement to start to hone in on who the perpetrator might be. Now, it's used in various countries around the world. It's not used here in the UK yet. So these days, people are using DNA to try and do things like predict what a criminal would look like. It's called predictive DNA phenotyping.
Wait. So that's taking the DNA that you had in that little layer, and it's saying, if I analyze those little clouds in that little layer, I can predict what somebody looks like. That sounds like science fiction.
That's what they're trying to do. So they're looking at genes that we know code for things like hair color, eye color. People are trying to look for genes to do with face shape. And they're even starting to analyze DNA where they hopefully are going to be able to say how old somebody was.
Thank you very much, Nita. I find it rather scary, I have to say, but isn't that the wonderful thing about forensic science? This is just science pushing the next step forward.
It is.
Thierry, thank you so much indeed for taking us through DNA. Thank you. Brilliant. And with that kind of science, this is what's making it more and more difficult for criminals, and hopefully making it easier for investigating officers to get to the person who's really responsible. So back to our murder mystery. Any more evidence that we could perhaps be looking for?
I've noticed over here, there seems to be some muddy boots. I'd be really interested in having a look at this.
Can take a photograph of those muddy boots for us, if you wouldn't mind.
There's some soil, potentially a soil expert might be able to tell us where that soil has come from, and some DNA from the boots. So I'd be keen to have a look at those.
A soil analysis expert. Where am I going to find one of those?
Well, can I suggest you ask your next guest?
It's a good idea. I wish I'd thought of that. Ladies and gentlemen, can I please ask you to welcome Professor Lorna Dawson, who's from the James Hutton Institute in Aberdeen. Lorna. The SIO has just said to me that he wants us to use mud to help us solve this crime. He's not serious, is he?
Well, yes, he is serious, because matching soils to location has a long history. Over 100 years ago, in this very city, Sherlock Holmes was able to work out which area of London he'd been by the colour and consistency of the mud on his trousers. And that was in a study of scarlet.
But Sherlock Holmes was a fictional character. What we're interested in is science and fact, not fiction.
Yes, but we can put that to the test. And indeed, we were joined by schools across London who took a sample of soils from their playing fields and sent it to us. And what we did was we analysed it. So, anonymised as School A. Have we got School A with us tonight? Yes. Brilliant.
Come on. Big cheer for School A.
And School C. So, we looked at all these characteristics which are linked to spatial information about those characteristics, so we could work out where they came from. What we've got here, though, tonight with us is a Raman spectrometer. And what it can do is it can look at the mineral grains that are in your samples. In your very samples, we will show them here tonight. And what we can get is a spectra from those soils. And here we have got the blue line, which is soil C, and the red line, which is soil A. And you can see there's a distinct difference in that spectra. These tell us about the inorganic silica, the mineral grains that are there. And this sample from that place was much more organic. And we know about the elements were there. And from that information, we were able to work out that soil A from School A was from Hornsey, North London.
Yay!
Am I right? Thank you. And soil C from School C, from the playing fields at your school, we think it was Camberwell? So now we are going to go to the whole of London again, where we can look at that sample from the boot. First of all, we are going to look at the areas that are diggable, so the areas that are not built over, and then we look at the texture of the soil. And from that texture, we know that the texture of the soil that was on that boot was a silty clay loam. So that corresponds with the spatial information of that colour of texture. And then we look at the minerals and the elements that are present in that soil. First of all, we've got cobalt, and then we've got the iron. We look at the distribution of chromium, and then we add in the element aluminium, building up these layers of information. And after we get the combination of information that is the same in that sample from the boot with the particular location, it narrows down to this dark purple area there. And
Whoa, wait a minute. You have gone from the entirety of the M25 to a little corner of somewhere because of soil.
Mayfair. We're in Mayfair. So we can now add in the organic information, the information about all the vegetation that's built up in that area, and that takes us even closer. It takes us down to a specific garden where we have that combination of plain horse chestnut and a combination of shrubs and grasses. And here we can see it could only have come from this garden.
Only have come from that garden. You think you're Sherlock Holmes, don't you? I think you're Sherlock Holmes, quite frankly. I just think that's amazing. So where is our sample from?
Well, I would suggest to go into that garden and have a look at it, to a specific area where you've got a plane tree, you've got this combination of information about that vegetation, which you get from pollen. So the palynology tells us about that mixture, horse chestnut, plane, and all these different shrubs, that we can actually probably go to the corner of that garden.
Lorna, I don't know. I actually have had my mind physically blown as a result of that. I think that is tremendous. And I know the work that you have done, you have helped out in so many live forensic investigations. Again, taking people to very, very specific spots. Please, thank you, Lorna, for me. Thank you. So, I think we need to review some of the evidence that we've got, don't you? Because I think we've come a long way in the murder mystery this evening.
Yeah, most definitely. We've got the traditional investigation evidence that's been recovered. So whilst I won't say we're there yet, we've got a good leg up, but plenty more to do.
Brilliant. Well, now I'm afraid our work might be finished, but yours is just about to begin, because you've got to go away, you've got to look at the evidence, you've got to start to build a case, you've got to find somebody that you want to question, and it will come to a trial. And this is the point where your interpretation of the evidence is so important. So I'd like you to thank our Senior Investigating Officer for this evening, but you've got a lot of work to do, so get on with it.
I'm going to get cracking. Thank you.
So I've just got something coming in. Oh, it's a shame that the SIO's just gone, because what we've heard back from a police force is that we have got confirmation that the DNA and the fingerprint have actually come from the same individual. And they've been able to name the individual. And what they're going to be able to do is they're going to be able to send us across a photograph, I believe, of the suspect that we might be looking for. Now, I think we have some serious questions to ask, because what it is saying in my ear, that the individual that they have identified is a seriously scary person who's got a very dubious past and has, in fact, been a very naughty boy, quite frankly.
You're under arrest on suspicion of murder. You do not have to say anything, but it may harm you, defense if you mention something in court.
He's going very quietly, isn't he? For someone who's so scary. Isn't that what forensic science is about? In all seriousness, what we've done tonight is we've found some evidence. We've been able to identify the evidence, to extract it, to analyse it, and to help an investigative force to start to look at that evidence and piece together what's going to happen. The SIO is going to be giving Dan a very, very serious talking to. And when we look at the third lecture in the Christmas series, what we're going to do is we're going to take science into the courtroom. And that's a scary place for any scientist ever to be, is in a courtroom. And it's not only the evidence that will be interrogated in the courtroom, the science will be interrogated. The scientists and their opinion will be interrogated. And only then, with members of the public, will there be a decision made. Thank you for playing along with our murder mystery.
Details of organisations offering information and support are available at bbc.co.uk/actionline.